just start by writing this as x to the minus 3, then the derivative thank you. Again, if you make this equal to 0, there's no solution to that. But if we look back at our original function here, we do have a non-permissible value. Again, x can equal 0. So when we make our number line with all of our critical points, we'd have 0 here. Kai, do you have the booklet for this yet? No problem. And if we try a number less than 0, a negative number, well, x to the 4 is always going to be positive no matter what. So it doesn't matter what number we put in, it'll always be negative. That means this function is always decreasing. Now, a couple things when we go to graph it. First of all, our non-permissible value means that we'll have an asymptote here. And just like last time, as the limit as x gets very large, either to positive numbers or very large negative numbers, is 0. So there is an asymptote at y equals 0 as well. In order for it always to be decreasing, and seeing the asymptotes that we have to start with values here in order for it to be decreasing, and then continue with the values on that side over there. Again, another thing that can help you is just some points. If you plug in 1 for x, you get 1, 1. And when you plug in -1 for x, you get -1, -1. That can also help you see what sections of your graph it has to be in. And again, you could have used the same technique if you start by graphing x cubed and put some points on there. And wherever you have an x-intercept, you have an asymptote. Because it goes to large numbers, you know it's going to be going to small numbers. And then when you go to graph it, you'd have this point again. Here you would have 2, 1 over 8. And that would have been the technique that we would have used in the past.